Okay, so know who is evaluating different investment options and wants to understand how the interest rate affects the growth of his savings. He is considering two options, one with annual compounding and another with quarterly compounding. He is also looking at the time it will take for his investment to double at a given interest rate required. Who invests in a savings account offering a nominal interest rate of 8% compounded quarterly. What is the effective annual rate for this investment? So the effective annual rate, this is the interest rate for the year after you take into account compounding. Okay, the interest rate for the year after you take into account compounding or after compounding has been done. Okay, so this is the formula. EAR equals 1 plus R over M. M represents number of compounding. So since it's compounded quarterly, so M equals 4. Therefore, quarters in a year. All right. So we're going to say 1 plus R. Our rate is 8%. Convert it into a decimal 0.08 divided by 4 raised to the power 4 minus 1. So we're going to do 0.08 divided by 4. That should be 0.02. Let's get my calculator to confirm this. 0.08 divided by 4. 0.02. So here we have 1 plus 0.02. That gives us 1.02 to the power 4 minus 1. And now do 1.02 to the power 4. That gives us 1.082. 0.82 minus 1. We get 0.082, which gives us an interest rate of 8.2%. All right. So after this 8% interest rate has been compounded quarterly, at the end of the year, the interest that you're getting is 8.2% from your savings account. Okay, part 2. If you know who wants his 10,000 investment to double at an 8% annual interest rate, how many years will it take for the investment to reach 20,000? So here we're trying to find the time, how long the investment is going to take. So we're going to use this formula here, the future value future value equals present value 1 plus R to the power n. So in our question, we already have the future value, we have the present value, we have our rate, but we're trying to find n. So if we have to make n the subject of the formula, first things first, we need to get rid of this PV here. So you divide both sides by present value. So the present value cancels out. So you now have future value over present value equals 1 plus r to the power n. So since we want to make n the subject of the formula, we need to drop it. So in order to drop it, we need to introduce logarithms. All right. So here on, so we're going to introduce logarithms both on the left hand side and on the right hand side. So we'll have log future value over present value equals n. So the n comes down. Then you have the log 1 plus r. Now we want to make n the subject of the formula. So again, you divide both sides by log 1 plus r. Okay, so you divide this side divided by log 1 plus r over log 1 plus r. So you cancel these, and then you remain with this formula here. N equals log fv over pv over log 1 plus r. So we're going to say log. Our future value in this question was how much? 20,000, since he wants his investment to double. So when we double 10,000, it becomes 20,000. So log 20,000 over 10,000 over log 1 plus, our rate was 8%. So here we have log 2 over log 1.08. Okay, so we say what is log 2? Zero point 301. Then log 1.08 is 0.033. So 0.301 divided by 0.033. We get 9.121. So basically 9 years. Yes, that's a long time. Just for your investment to double, 9 years. Colleagues, is it worth the wait? Can you wait for 9 years for your 10,000 to double? Yes, that's how we find the n. Then part 3, Nuhu is considering a 5-year investment and wants to determine the interest rate required to grow his 15,000 to 20,000. What is the required interest rate? So again, we're starting with this formula. Future value equals present value 1 plus r to the power n. Now in this case, we are looking for r. Okay, so first things first, get rid of the present value. So you divide both sides by PV. Okay, so you have future value over present value equals 1 plus r to the power n. Okay, so next we need to get rid of this exponent, this n. All right, so the way you get rid of this exponent, you bring in the reciprocal. Okay, you multiply it by its reciprocal, 1 over n. And what you do on the left hand side, you do it on the right hand side also. Okay, so when we multiply n times 1 over n, these n's cancel each other out. All right, so we have future value over present value to the power 1 over n equals 1 plus r. And then all you need to do is you take this 1 over the other side and it becomes minus. Okay? Yes. So in this question, our future value is 20,000. Present value 15,000. The power 1 over the amount of time, I think it was 5 years, if I'm not mistaken. 5 years, yes. 1 over 5 minus 1. Okay, so it's 15,000 divided by 20,000, or 20,000 divided by 15,000. Get 1.33. Okay. This fraction, you can convert it into a decimal. 1 divided by 5 is 0.2. Okay, so that you can easily do it on your calculator. 1 divided by 5, 0.2. So you're going to say 1.33 to the power 0.2. We get 1.059 minus 1. 1.059 minus 1, you get 0.059 into one decimal place. I mean, round off 0.06, which is 6%. Okay. That is the rate.